The sixth and latest IPCC report on the risks of climate change recently came out and, for the first time, mentions cultured meat and cellular agriculture as possible solutions for climate change mitigation. Let's see why this matters and why I believe the IPCC drastically underestimates the potential of cellular agriculture to avoid the worst consequences of catastrophic climate change. Hello world! This is the Impact Investing Show, where we invest in a future for all conscious creatures. I'm Lennart Schelter, welcome to the show. As most of you may know, the sixth report of the Intergovernmental Panel on Climate Change was published recently and doesn't exactly paint a bright picture of our collective future. To illustrate, here's what Antonio Guterres, the General Secretary of the United Nations, said about the findings at the launch press conference. An atlas of human suffering and a damning indictment. Nearly half of humanity are living in the danger zone. Many ecosystems are at the point of no return now. The global energy mix is broken. I don't know about you, but to me, that sounds pretty grim. The report has more than 3,600 pages, and many people provided summaries and comments on the report as a whole, so I'm not going to do that here. Instead, we are going to focus on the role of cellular agriculture in climate change mitigation, because for the first time it is specifically mentioned in the IPCC report. First, let's see why replacing conventional animal agriculture is so important for climate change mitigation. Then, we're going to look at what the IPCC report has to say about the potential of different food system adaptations, including cultivated meat, plant-based alternatives to meat, and some other options. Lastly, I'm going to address some points in the report regarding CELAC that I find a little misleading, so stick around for that part before dismissing the mentioning in the report as insignificant, because you might get that impression otherwise. Overall, I believe the report massively underestimates the potential of cellular agriculture for mitigating the consequences of catastrophic climate change, and I'll tell you why. Let me know if you agree in the comments. So why is our food system so important for climate change? In this figure by Our World in Data, you can see global greenhouse gas emissions of food production. You can see that food production overall is responsible for 26% of all emissions. So we are talking about more than a quarter of all global emissions caused by food production. Splitting this up into sectors again, we can see the major contributors. I talked about this in much more detail in my previous videos on global meat production, fish production, and the egg and dairy industry. There I discussed the impacts and scale of these industries in more depth, so check those videos out if you're interested. They are linked in the description. Back to the figure. Let's start from the top and see how cellular agriculture could change these numbers. Retail will stay pretty much constant, so does packing. But transport will probably be reduced by a lot. With cultivated products, we don't need to ship feed for animals halfway across the globe, and will have much more distributed production with many smaller facilities instead of the centralized super factory-like slaughterhouses and industrial farms we currently use. Food processing will probably increase or stay constant, especially the plant-based alternatives are quite heavily processed foods actually. Then the tiny bar, the 1% there, is wild catch fisheries, which might entirely disappear. Then there's the big one, livestock and fish farms. Now, in my expectations, these will entirely be gone in about 20 years tops and rapidly decline until then. So this whole chunk, 30% of the food emissions, could be eliminated with cultivated and plant-based meat alternatives. This is huge. Next up are crops for animal feed. These will obviously disappear alongside the animals they are produced for. No animals, no need to feed them. Crops for human food will likely increase because people will start to eat more real food like good old rice and beans, maybe not directly, but processed into meat-like substitutes and alternatives. Land use for human foods will also likely increase slightly or stay constant due to higher efficiency of modern agriculture. Finally, the land use for livestock will also disappear almost entirely, since very few people will have cows or chicken without an economic incentive, and the animals will adopt the role of pets more than farm animals. Overall, based on these numbers, I believe we can expect a reduction of at least 50% of emissions by replacing purely animal products with cultivated production. Obviously, cellular agriculture is not free either and also requires resources, energy, and it may also cause emissions. We're going to get to that in a minute, don't worry. So our food production causes 26% of all emissions, and we might reduce them by up to 50% by cellular agriculture alone. So that would be 13% of all emissions, a significant portion. Now that we know how important the food system is in reducing our global emissions, let's look at what the IPCC thinks about it. In the report by Working Group 2 on the risks and vulnerabilities, it is written, alternative protein sources for human food and livestock feed are receiving considerable attention. Laboratory or clean meat is one potential contributor to the human demand for protein in the future. Such technology may be highly disruptive to existing value chains, but could lead to significant reduction in land use for pastures and crop-based animal feeds. The impacts on greenhouse gas emissions depend on the meat being substituted and the trade-off between industrial energy consumption and agricultural land requirements. So far, so good. They recognize cellular agriculture as disruptive and see great benefits in land use change, but also mention that emission reductions depend on which meat is replaced. Obviously, replacing beef is more effective per kilogram than replacing pork, but replacing chicken is more effective in absolute numbers than replacing pork, and so on. Additionally, the source of energy used for bioreactors plays a major role. If it's sustainable energy, great. If not, the emissions for energy production need to be accounted for. There is another interesting section saying, changes on the demand side as well as improvements in resource use efficiencies within the global food and other bio-based systems can also reduce pressures on the remaining land resources. For example, dietary changes toward more plant-based food, where appropriate, and reduced food waste can provide climate change mitigation along with health benefits and other co-benefits with regard to food security, adaptation and land use. Duh, Captain Obvious. This is so blatantly clear by now that it shouldn't even have to be mentioned. But they are absolutely correct nonetheless. We could just as well simply stop eating meat and wouldn't have to figure out this whole cellular agriculture thing. Would be a lot easier. Probably will not happen though, so cellular agriculture is the next best option. The quote goes on. Advancements in the provision of novel food and feed sources, e.g. cultured meat, insects, grass-based protein feed and cellular agriculture, can also limit the pressures on the finite natural resources. I agree with almost everything here except for the insect proposition. That's just an unnecessary transitional step, as useless as hybrid cars carrying around two motors because one wasn't heavy enough. But that's a topic for another day. So far, these quotes were from the second report of the IPCC report. There are 3 parts overall. The third and final part focuses on mitigation of climate change and goes into a little more detail regarding solutions for the food system. In particular, they summarize a host of mitigation solutions within the food system in a table you can see here. On the left, you can see the name of the strategy or technology. In the second column, the direct and indirect effects are listed, with an arrow pointing up indicating an increase, an arrow pointing down indicating a reduction. The third column summarizes co-benefits and adverse effects in a similar fashion. Again, no big surprises here. Dietary change is the first suggestion and has no adverse effects listed. Just eat your veggies, people. Simple stuff. The other options here are interesting as well. Especially gene technology already had and will have a massive effect on our ability to feed the world. If you're not familiar with previous successes, read up on the origins in the Green Revolution and continued development of more productive varieties of different food crops since then. Fascinating stuff. But for now, let's continue on the second page of the table, where we have our insects again, as well as algae, which I think is a really good option, by the way, and then there are plant-based alternatives and cellular agriculture. Plant-based options are fairly straightforward, nothing new here, so let's get to the exciting part. For cellular agriculture, they mention many of the benefits like no emissions from animals, high efficiency and reduced food loss and waste, which is all true and great. What I am missing, however, are the massive savings in land use and water use. Remember that cultivated meat uses, depending on the study, around 90% less land and water compared to conventional beef. Under co-benefits, they mention animal welfare, of course, very important point, and a reduction in emissions of reactive nitrogen and other pollutants. This refers to the reduced use of mineral fertilizers, of course, of which nitrogen is a major component. We would not need to grow and fertilize all the feed for the animals, so the use of fertilizer would drastically fall with the cellular agriculture system, which is great news for the soils and the groundwater bodies, and a huge factor for food security as well. Currently, we are highly dependent on fertilizer and it will not be available forever. Supply depends on a few key exporting countries and so on. Therefore, reducing dependency on fertilizer has great security implications as well. Another point is reduction of risk from zoonotic diseases, pesticides and antibiotics. Same game here, less animals, less of these stupid problems. Regarding the last point here, research on safety aspects needed. This is true and is basically the regulatory challenge ahead of cultivated products. Their safety needs to be tested and they need to be approved by regulatory bodies in order to hit the mass market. But there are many companies and organizations already working on it. New Harvest, for example, one if not the OG NGO company in the cellular agriculture space, has a program specifically aimed at these challenges that is currently seeking funding. If you're interested, I have linked the information below. Companies like Perfect Day have already received FDA approval for their whey protein, a flora-based replication of the bovine-based beta-lactoglobulin protein produced using a genetically modified Trichoderma rese yeast strain. This is precision fermentation at its finest and produces a milk-like product used in dairy products that are available in standard supermarkets in the UK right now, for example. Impossible Foods also gained FDA approval for their soy legumoglobin, which gives their burgers the bloody look. So there are clear paths to follow for regulatory approval and companies are actively seeking to improve the cooperation further because everyone knows that regulation and approval are critical for mass adoption. Now the juicy point, energy consumption and connected emissions. In the table here it says energy needed will increase. I believe this is a somewhat misleading formulation and invokes incorrect assumptions. Let me explain. First of all, I am not sure why they would say the energy demand would increase. There are some studies trying to estimate the lifetime assessment of cultivated products, but we cannot really know any reliable numbers until an industrial scale plant is actually operating and in production. The second point is that energy in cultivated products is mostly used in heating and stirring the tanks for the cell cultures. This energy can very easily be produced sustainably using wind, solar and battery systems. And in the end, it's not about how much energy is needed, but how much emissions are generated in the production of that energy, which will be negligible with entirely renewable systems of energy production. Conventional animal agriculture, however, cannot easily eliminate their emissions as they are largely caused by land use change, burning down forests to make room for pastures and fields of soy monoculture, for example, and of course the farts and burps of the cows. In the IPCC, there are mainly two sources cited. A study by Torres and Vandenberg, which, surprise, surprise, has restricted access thanks to the most horrible spawn of misguided capitalism that are academic journals, blocking access to the world's knowledge without providing any value whatsoever. The other important study they quote is by Hanna Tuomisto, a researcher from Oxford who published the first ever environmental impact assessment of cultured meat back in 2011, and is now quoted with a more recent study from 2019. In the study, the researchers provide this informative figure, which shows the energy use, greenhouse gas emissions, and land use of different protein sources. You can see that energy use of cultured meat is indeed quite high, even compared to beef and pork. However, the greenhouse gas emissions look much different. Still surprisingly high, don't you think? Similar to meat substitute, more than poultry and on par with pork. I agree, but wait. In the study, the authors explain that the models assume the use of the currently common sources of energy in the study's regions. In most cases, that does not mean high percentages of renewable energy. The environmental impacts might therefore be substantially lower for low-emission energy sources, as discussed earlier. The authors also mention that the land freed up from conventional production is not considered in these calculations. A small portion of that freed up land would be enough to produce the energy needed for cultivating technology in a sustainable way. The rest of the land might just be converted to natural grassland or forest, storing tons and tons of carbon, which is a huge additional factor not included in these numbers. So we should not just take these numbers and compare them one to one, because there are additional factors at play, like the positive land use change, etc., that are not included. Not to mention all the benefits of reducing water consumption, eutrophication risk, all the animal welfare issues, the dangers of superbugs, and the list goes on, beyond just energy consumption. Now for my final appeal. it is great to see cellular agriculture recognized as a possible solution in such an important document as the IPCC report. But I have to ask, why so late and why so little? There are massive positive impacts that can be gained from adoption of cellular agriculture faster and more broadly that range from environmental to social to economic, and they affect animals and humans alike in profound ways. There are some hurdles like regulatory approval and the energy consumption. But as we talked about it, these are already being overcome left and right and the solutions are already there. It's similar to FBS. Fetal bovine serum used to be the Achilles heel of cultured meat, at least that's what proponents thought, until it became obsolete for most companies and now is not even a relevant criticism at all anymore. And advocating for cell ag would fit the goals of the IPCC very well, I believe. For example, water scarcity is a major theme throughout the entire IPCC report. Guess what? Cellular agriculture will lead to massive savings in fresh water. And the best thing is, the savings accumulate at the source, where the feed for the animals is irrigated, often in developing countries with existing water scarcity problems. And talking about the massive savings in land use, just as a thought experiment, think about the CO2 sequestration that would happen on all this land if we don't use it for pasture and monocultures anymore, but let nature do its thing and grow plants, grass and trees that store tons and tons of carbon. I see much more potential in cell ag for climate change mitigation than the IPCC appears to do. And I hope they will intensify their consideration of cell ag in coming reports, alongside growing literature on the topic and the products, and on the market with provable superior life cycle assessments compared to any traditional animal agriculture products. That's it for this video, people. Let me know what you think about the IPCC report, and if you also believe that cellular agriculture might play a pivotal role in climate change mitigation. If you found value in this, do all the clicky stuff, you know the game. My name is Leonard, this was the Impact Investing Show, and because there is so much going on in the cellular agriculture space, I will see you in the next one.